Hey there, Math 30-2. I'm just going to go over this formative lesson 7 here, dealing with exponential solving equation here. So first things first, let's solve this equation where you have 2 to the x plus 1 equals to 5x plus 1. Okay, it would be great if they had the same base. If this was 2 and this would be 2, because then you would actually have the opportunity to just play with the exponents, but unfortunately they're not. So in this case, we have to do an extra step here where we have to log both sides. So if you log the left-hand side, 2 to the exponent of 2x plus 1, same thing on the right-hand side, 5x plus 1, and log that side. Now we can actually apply an actual rule which we learned in this topic, where we can bring the 2x plus 1 over, same thing for x plus 1, in front of the log. So then I shall do that, 2x plus 1, log of 2, and then same thing right over here, x plus 1, log of 5. Now with this in consideration, we now can use the distributive property. And that means we're going to distribute property with the 2x with the log of 2. And then the same thing with the 1 with the log of 2, which is the same thing as saying just log of 2. And same thing on the right-hand side. Then you're going to be doing x times log of 5. And then 1 times anything will be the same solution. So that would be log of 5. Okay, so our next goal is to actually factor out the x. So we need to move usually the smallest x, which in this case is this one right here. And I'm going to move this one over here. This is gone now. So what do we have left over? We have the following. At the same time, I want to move the log 2 because we want to isolate the x on one side. So I'm going to do negative log of 2, negative log of 2. Rewrite it so it looks nice and pretty now. So what do we have left over here? 2x log of 2 minus x log of 5. That's good because now we could factor out the x, which we'll do right after. Let's just move the logs here on this side. Log 5 minus log 2. Okay, what do we have to do now? Well, as I said, factor out the actual x. And what's common between 2x and x is an x. So that leaves us with 2 log of 2 minus log of 5. And on the right-hand side is still the same thing. So the beauty is now we have x by itself once we divide by 2 log of 2 minus log of 5. And do the same thing on the right-hand side. Log 2 log of 2 minus log of 5. I'm finding with your graphing calculators, what ends up happening is you have to do this separately. So keep in mind, this is crossed out now. So what do we have left over here? Is that we have x equals log of 5 minus log of 2 over 2 log of 2 minus log of 5. So in your calculator, you're going to type in the following, log 5 minus log 2. Keep in mind, it's a base of 10, so it's automatically just press the log button, and that gives us 1. Now when we do the bottom part, 2 times log 2 minus log of 5, you get negative 0.0, negative 0.096. It keeps going. So this is where you would actually keep this value in your calculator, do 1 divide by that, and you will get a solution in the end of negative 10.319, 3 decimal places. Well, how do you check? Did you do this correctly? So, of course, what do? We go back to the original equation. Substitute that value in there and check if they're actually the same. So 2 to the exponent of 2, negative 10.319. Now don't forget, keep the value in your calculator. Add it to 1. Do the same thing on the right-hand side. 5 to the exponent of negative 10.319. And then add that to 1. Okay, so when you do that, you should be able to figure out if they're the same on the left-hand side and the right-hand side. If I'm not mistaken, it is. And what you're going to be doing, if you actually calculate that on your calculator, 2 to the exponent of 2, open bracket, negative 10.319 plus 1. It's roughly 1.2256 to the exponent of 6. Same thing if you do the other side, 5 to the exponent of negative 10.319. Keep that value in your calculator, which you had earlier, and then plus that to 1. And we get a very similar answer. So they should be the exact same answer, but keep in mind it all plays a factor if you don't put this the same value that you got when you did 1 divided by negative 0.096, that value you got earlier. So this is how you solve anything with a different base. You always want to log both sides, and then from there try to factor out the x once you do the distributive property, and then you're set to go to actually move it to the right hand side. You're isolating x, and then go forward from that. Hopefully that helps.